of the slice for the Norwegian Defense that we have been working on. And the implementation that will be presented today is a collaboration between the company on the bottom here, Telenor, Nokia, and PaloAlto. So the agenda for the demo is as follows. So the agenda for this session is as follows. I will give an overview now to start with. It will be about 10 minutes. Then we will have a demonstration from Nokia on how we can deploy the VNFs or the applications across different cloud sites. So we have the central sites and we have the edge. We will show how that is being done from an orchestration point of view. Then we will also show how we do the provisioning of 5G users into the slices from the end-to-end orchestration system. That will also be done by Nokia. Then we will move over to the actual demo where we the users being connected to different slices and how we do that, and also how we can do some differentiation among slices. That's why I'm in the car here, because we are on site and ready to do the demo afterwards, if everything works as planned with the provisioning and everything. And then eventually we will also have a demo on the security service from PaloAlto that we are working on. And then I will also leave some minutes for questions at the end. There are many participants in the meeting, so we have people from the Norwegian Defense. I also think people from NSM, the National Security Authority in Norway, and potentially some other partners from the defense on application providers. And then we also have Telenor people here, people from Ericsson, Nokia, and PaloAlto. So let's start. So just to recap on what 5G-VINNI is, it's a European research and innovation project. And the vision is that is to build a 5G end-to-end facility so that we can demonstrate that we meet the 5G KPIs and also test different vertical industry use cases. It's a 3-year project and we are over halfway through it. And we are getting a lot of results. And you see the partners at the bottom. I will not spend too much time on talking each of them, but it's a really strong consortium able to deliver on the ambitions. Then we also have an external stakeholder board, where, for instance, the Norwegian Defense is in, and other vertical industries like transportation, shipping, and so forth, e-health as examples. Over again on the slide. So we have this is kind of the network architecture where we have the base station, 5G radios, transport network, the core, and the cloud. Then we also have the end-to-end orchestration and automation on the top, where we actually orchestrate the network slices. And just to show you how the different partners deliver into this picture, we have base stations from Ericsson and Huawei. Today we will show you the Ericsson part on the base station. And then the transport network is from Telenor, it's the commercial transport. Then we also have the cloud technology that you see here from Nokia, and the mobile core, the virtualized network function from Ericsson. Then we have the end-to-end orchestration and automation from Nokia to implement the slicing and the fulfillment of slicing. And PaloAlto is delivering security and firewalls. That's the picture. Then what we are going to demo today is the defense slice, and this is a quite advanced service, putting a lot of new requirements on the network, where we think 5G is really important to deliver on that, and of course network slicing. What we do together with the defense is to implement a dedicated network slice with full isolation. And within that, we also deploy services such as voice and push-to-talk. One important requirement is end-to-end encryption. So that is in implementation right now. And we're also working hard to get priority when they need it, so that when they connect, it should be able to prioritize them in case of a disaster or war. It doesn't mean that prioritization is needed all the time, but if there is a disaster or war happening. And then we have the autonomous mobile edge, which is very important to them as well. And we also see that being very important in other industries, such as the hospitals and so forth. And the way to explain that is that basically we have the central data center delivering the services, but we are also deploying edge data centers to lower latency. And one application for the defense that is important there is, for instance, drone control to achieve low latency. But another thing that is even more important, which is back to the autonomous mobile edge, is that in the case this link breaks down, they want all the customers connected to that edge to still be able to communicate with each other. And that's where we are able then to spin up the full mobile core in that edge, so that we can give a local mobile network in the area covered by the edge. So this is a really important part for them. And the fifth point is also having the option to have different type of backhauls for redundancy. That's where we're also looking into connecting satellite into to 5G, where Telenor Norway will be providing the satellites for the demonstration here in 5G-VINNI. Then the last part from me here before I leave the floor to the people who will actually demonstrate things is to show you the slices that are implemented. And start from the bottom, we have the slice for the defense. And that is, you can see that it's deployed both in the central side or in the core site, but also in the edge. And you see how we deploy all the mobile core network functions. So this is the non-standalone setup with EPC connected to 5G to start with. And we have the full mobile core both in the central site and the edge, and also including IMS. And then above that, you can see the NSA slice 2, which is for massive IoT. And then you have NSA slice 1, which is for enhanced mobile broadband. Those are, we are going to demonstrate today the defense slice and also connection to the EMBB slice, and show how we can differentiate between those with different capacities. And on the top, we are working on the implementation of standalone 5G, which is real 5G. That will come later. So the expectation is to have that ready before summer, so that we can do real slices. Okay, so that's it from me. Then I will leave the floor to Antonios. So Antonios, please take the floor and dive into the deployment of VNS across central and edge sites.
Okay, thank you, Paul.
Antonio, maybe.
Excuse me, Antonios, before you continue, Martin, are you online? Could you please go to the participant menu, the tab on top of the WebEx, and disable the entry and exit tone, and also mute all, okay? Then you unmute each one as required.
Okay, let's go. Okay, good afternoon, everyone. My name is Antonios Dimitriadis. I'm from a Nokia software team. I'm the Telco Cloud Solution Architect in 5G-VINNI, and mainly I work on the NFVI man on the automation. So in the last demo, like almost 2 months ago, we saw how we can deploy in automated way a whole slice in the core side. That time we had only one side, but now we have the second side, the edge. So especially for the defense slice, we have this multi-site deployment. So some components, they will be in the core side, sometimes they will be at the edge side. So now we are going to deploy here some VNFs to simulate that environment. So yeah, as an introduction, here is the current infrastructure that we have here. So here in the red box, we see all the management components that we use. It's based on the HCNV architecture. So we have the MANO that comes from Nokia mainly, about the NVO and the VNFM, the generic VNFM. And then we have the specific VNFM that comes from Ericsson. And then of course we have the service orchestrator. And then we have the NVI architecture here with two sides. One is a central site where we demonstrated last time, where we use NCIR, which is the OpenStack based Vim. And then we have the edge side, which is also based on the OpenStack, but there we don't use the SDN solution. It's pure on the neutron networking. And yeah, for deployment now, the management will be only in the core site, and then they will be able to manage all the VNFs in all edge sites. Even in the future, we expect to have more edge sites there. And now to achieve that automation, it's not a straightforward process. We need to have a lot of preparation. This is also a slide that I showed the last time. So this is a component that is here. The flow one is a service orchestrator, and CBAD is the NFVO that they lead mainly the whole orchestration. And then there are several other components about the firewall. We use the PaloAlto. We have the provisioning gateway. This is another demo that we see later. So from flow one, for example, we can not only we deploy the whole slice, but we can also provision the user. So immediately after the slice is deployed, the users can use the services. We have, of course, the networking equipment, and then we have also the VNFMs. So for all of them, we have developed several APIs. As we see here, it's a huge list of APIs that we have done, and still working on some of them, or we keep adding new features there. So all of them, they play a vital role in the slice networking. And now for the today demo, we are going to see for the two main sites. One is the core site and the other is the edge site. So as we see, they are very common. I mean, comparing the equipment and the nodes that we have delivered there, except the networking part. So in one case, we have Nuance that offers our SDN solution, and in the edge side, we have the Z9100, which is a physical switch. Now, as a step, we see how from the CBND, the NFVO that we use here, we can deploy two VNFs. One VNF will be at the core side, and the second VNF will be at the edge side. We will also configure the network, so all of them should be accessible. And then also can configure the firewall. Now the VNFs can be from different tenants, can be from different vendors. So for example, at the core side, we may have a VNF that comes from Ericsson, and the net side, we may have another VNF that comes from MetaSwitch, or even from the defense. It could be an application function. It could be anything. So it doesn't mean that we need to deploy the VNS from the same vendor. A network service can have a VNS from different tenants and different vendors. So the first step when we deploy the service is we need to create the networks. That will be for both, for the core site and the edge site. The second step is that we go to configure the firewall. That will be in a panorama. So there is an exposed API that will be for the core site and edge site. And if we're going to be precise here, the panorama is centralized. So we just configure the same panorama nodes, and then from there they go to configure the edge or the core site. So this is a logical view. And then the main step is that we need to deploy the VNF. So once we prepare the whole infrastructure, then we can deploy the VNFs. So from the NFVO, using the SOL3 interface, we instantiate the VNFs. And then from CBAM, we will deploy the VNF1 at the core site, and then the VNF2 at the edge site. And then, of course, we will see at the end that we'll have the two VNFs, the two that they are one VM each one with a specific IP address. And then, as we see here, they come from a different security zone. So one belongs to the management, and the other at the edge belongs to the default. And then we see also the PaloAlto configuration is different. So that's the concept here. So we are going now to connect to our CBND, which is the NFVO, and then see how we can deploy that service or slice. So this is our NFVO, the Cloud Band Network Director, and this is a catalog. Here we upload all the needed NSD. So when we deploy a service, first of all, we need to have the package uploaded. That has, for example, the Tosca templates and the manifest that we use to deploy that one. So this is the package that we're going to use. We can create here the instance the network service, we can use any name, for example, demo defense. And then here, the template is common. We can use the same template, and then we can deploy the same service again and again in multiple sites. So that's the idea of the template. The only difference is the input parameters. So per site or per slice, we can have a different JSON input file where we can set there how this can be deployed. For example, what network we need to deploy, how many VNFs, what type of VNFs, etc. So this is a dynamic part. So we have already a JSON file prepared, which we can import it now. So as you see here, for example, for this specific slide, we create specific networks here. So we have a specific subnets. So if we go to deploy this in the Edge 2, later maybe we have a second defense slice in another site, then the IP addresses will be different, and those come from Telenor. So we just need to update those data. So here we see the whole list of this slice, and then we create it. So now the next thing is about the placement. Now we created the template. Now we want to say which nodes are going to be used for this slice. So the first thing here is, as you see here, is about the core placement. So what we are going to use in the core side, because maybe we have multiple SDN components or networking things. So here we choose what is the SDN. So here we have the SDN controller that comes from NUADS. The VIM will be the NCIR at the core side, and then the tenant that we use there will be the CBND. Now, also we may have a multiple VNFs, so we need to choose which VNFM. In our case, we have two, as I mentioned. One comes from Ericsson and one comes from Nokia. So in this case, we go to use the second VNFM that comes from Nokia, because we are going to use a generic VNFM. And then for this VNFM, the resources will be deployed in the VIM at the core side, and then the tenant again will be the CBND. That's the first step. Now we are going to say which resources are going to be used in the edge side. So here you see the second part is about the edge placement. So here we have a neutron. We don't have an SDN solution, but we have the pure OpenStack neutron. The tenant in this case, as I said, is this a multi-tenant deployment, so it will be admin. The VNFM again will be the CBAM from Nokia. VIM will be from the edge side, and then the tenant will be the admin. So once we put all this information, now we are in position to deploy the whole service. This is triggered. Yeah, as we see now, this is deploying. And now if we go back to our OpenStack horizon, here we have the two sides. The 10.11 is the edge side, and then the 10.0 is the core side. This is the two VIMs that we have. So it may take now some minutes, but yeah, we will see here that those VMs will be deployed. And then in NUADS here, especially for the core side, we will see now that the networking part will be completed. As I mentioned, this will be in the CBND. So here, the new network will be auto-created soon.
And I can confirm, Antonius, that the networks have been created already on firewall. I just checked that.
Okay, that's good. Then maybe at the end we can try to ping, because this is very important. We have now some, as we see, some VNFs in the core side and some at the edge side. So we define those tags in the firewall, so we should be able to ping, for example, to communicate from the core side to the edge side, or if the policy for that service is to ping from the edge side to the core, then we can also adjust the firewall policy to do that one. So as I say, we don't only deploy the VNFs, but also we need to be ready to use the network. That's why we can try also to ping those VMs. So yeah, this is as we remember here before, the subnet in one side didn't exist before. So now we have already created that subnet, and then a VM is going to use that one now. The VM is already deployed. So as we see here, there's already a VM port allocated for this. So if we go also here, this is the edge side, we will see there is a new VM just deployed here with this IP address. And then we see here that it's deployed just 0 minutes ago, so it's a very, very fresh. So this is the first VNF that we have at the edge side. And then this is for the core side. So also here, we see now it's already deployed with this IP address, the 10.52.128.50. This is exactly the same one that we saw before here in NUADS. And now we may try to connect to one of those VMs. Let's take this one, the IP address of this. And then here we can see the IP address of this. So it's exactly what we have done. So now, for example, if you want to configure something more in this VM, since you have SSH access, as we see here, we can access it even from my home using VPN. You can go and configure or do whatever you want into this VM. Now, if we ping, let's try to ping to see if this works. Yeah. So as we see, this is successful. This IP address is the VNF that comes from the edge side, the 10.11.200.5. So if we go here, this is the VM that we have just deployed 2 minutes ago at the edge side. And then the IP address is the 10.11.200.5. So as we see now, from the core side, we can pick to the edge, but the opposite is not allowed now because we block that traffic from a firewall policy. So yeah, that's a... And now if we connect also here to the CBAM, this is a VNF manager, we can see the two VNFs deployed. So this is the slice 1 VNF1 that has been deployed in the core side, and then the VNF2 has been deployed at the edge. So both of them have been completely instantiated and they're successful here. We see it in green. So yeah, the whole slice looks like working fine. And we demonstrate also with the ping test. So that's from my side, a quick demo to show how we can deploy a multi-site slice. Any question? Or any clarification? Okay, then yeah, what we try now in the future as a next step is to introduce in edge side the Ericsson VNFM. So in that case, we can deploy the Ericsson VNFs and then use them there to test the whole slice. That's the next step. The edge side has been deployed some weeks ago. So it's already integrated to the Nokia's VNFM, but not yet to Ericsson's VNFM. But yeah, I think that will be very, very soon. And then we will be also in position to test that part. Yeah, Paul, back to you for the next demo case.
Thank you, Antonios. That's great. Thank you so much. So then we will move over to Tirta, who is going to present the UE provisioning from the end-to-end orchestration point of view. So Tirta, please take the floor.
Hello, hi everyone. Thanks, Paul. Thanks, Antonios. I'll share my screen. Yeah, so just to recap a bit, like Antonio said, from 2 months before, so it starts from the slice orchestration. So you already again saw this NSD from Antonios's demo. So yeah, from that it goes to the catalog of flow ones catalog where we design the slice based on several NSDs. We just for in this case it would be like NSD for the core site, and then for the another NSD for the edge, let's say. And then once this design time part is over in this catalog vertical, then we move to the action part where we place order like ordering a network slice as a service, and then we place that order. It comes to flow one, and flow one then triggers again CBND to create an instantiate or terminate and delete. So these are the use cases for operations that we can trigger for the NSD. So, and then at the end, when the slice is up and running, so that's the network services. Several network service instances would compose this end-to-end slice. So that's the slice end-to-end slice orchestration part of the story. And then here, like Paul said, it's more about the UE provisioning. So once the slice is up and running, so we onboard UEs. So that's now this is the now on your right. What you see is the slice is instantiated already. Slice is slice one, so that's the identifier of the slice. And the VNF instance that we are concerned about in this demonstration is the VHSS of slice one. Okay, so here again we get the provisioning specs from VNF vendor. In this case, of course, this is VHSS is coming from Ericsson. And then we consume this in our catalog to build a user equipment of 5G SIM card kind of spec. And then this is again the design time thing. And then we move to some action. We place a post service, and we are using activation TMS specs here. I mean, earlier for the service order and network slice as a service kind of ordering, we were using TMF 641. Here we are using 640, and then we place this order from here. In absence of a proper BSS, of course, we are using this Swagger UI as a order payload submission portal, and then it comes to flow one again to add is the use case that we will see, and then it moves to you'll see from our colleagues from Ericsson that how the UE looks in the VHSS. Okay, and then so this is what we will do, and now in slice one, and then again on the defense slice. So that's on the edge. Okay, so back to this one. Yeah. Now on the real screens. So here you see in the Flow One's catalog that it's the HSS create. This is the 5G UE spec. So TP UE is the spec name, and what we are doing in this TP UE is that we are creating the UE on the VHSS. Now on to this Swagger UI. So we got same information from our colleagues in Ericsson. So this is one of the IMSIs that we will provision on slice one, and with the profile ID S3 Gold. And as you can see, it's specifying that we need to call the TPEV specs from Flow One's catalog. This is authorized, this portal, this submission of this payload. And then I say execute here. And then it returns this ID 474. If we move to this Flow One order management portal and say search, then you see this 474 has actually created this UE on the slice one's VHSS. Okay, similarly, I will continue to do provision this one on this same MC on the defense slice. With the same profile. And again, say execute. So this is the next counter in line. So that's the service ID. And if we again go back here, so you see that one. So we got another SIM card. So for this demo, so provision that UE as well. It's just 6 instead of 3 and the last digit. So everything else remains same. I'll change this one to slice 1 first. Doesn't matter, but just for the sequence of things. Okay. And then this is 476. Of course, it went again to the order management. And yeah, that's 476 here. And then again, we need to do it on the defense slice. And we say execute again. If we see here, then it's 477. And just to touch this point that when it's defense slice, it goes to the other VHSS. Yeah, so that's all. I guess from the UE provisioning point of view. So we saw this ad at least. So yeah, over to our colleagues from Ericsson. Thank you. Please feel free to ask any questions if you have. Okay.
Okay. Thanks, Tirta. So any questions to Tirta before we continue? All right. Good. So thanks again, Tirta. It's good. So now the UIs should have been provisioned into the 2 slices. And then if that is working fine, then the rest of the demo should work fine as well, hopefully. And that's what we will see now. And then that's where I will leave it over to H and Erland from Ericsson to take us through that demo. So please, H and Erland, please take the floor.
Hi all. Let me just share my screen, please. Can you see my screen? Okay. Okay, so I am Hrvoje Marinovic from Ericsson. I'm a solution architect. My name is a bit complicated, so everybody just calls me H. And I will be now talking a bit about attaching the UEs to different slices and how to differentiate the UEs and where they will occur. So the first thing is the picture that we've already seen today, and this is the layout of the 5G-VINNI facility here in Norway. What is important for us at this moment that we will be presenting is the slice 1, the NSA slice for mobile broadband, and the defense core site, which we will be calling slice 3. So this is slice 1, and we have slice 3. What they have in common is the radio access part. So we will be connecting via the same radio, and the differentiation between them will be inside the core. You will note that we have 2 instances of packet core. So there is one in slice 1 and one in defense core. The HSS that is going to handle the usage type for this is in both the slice 1 and in the defense core slice. Somebody please mute. Okay, great. How the mechanism for doing this is the D-core mechanism. The D-core is dedicated core network, and this selection is relatively new. This allows us to deploy multiple dedicated core networks that are connected to the same radio access part, but the differentiation between them is per usage type. So the parameter UE usage type is provisioned in the HSS per subscriber. So each subscriber will have one and only one usage type assigned to it, and this will tell MME where the UE is going to register. When this usage type is changed, the UE can go to any other slice, but it will always go just to that one slice. So there is no case where UE will register in a slice it is not assigned to. In our case currently, we are using random initial MME, but this can in live network be fixed to a certain default MME, which is then going to reroute any subscriber to its assigned packet core. So in short, this is how it works from a standard perspective. UE sends the attach request, and it lands either on a default DCN, dedicated core network, or it lands on a random one. The MME, if this is the case of the initial attach, will ask the HSS for the information about this subscriber. In the authentication information answer, the HSS will send the UE usage type that will tell the MME where exactly this subscriber should be located. Now we have 2 cases. In case A, where the MME that initially received this attach request is the one that the subscriber should be on, the attach procedure continues as normal, as is default for a long time now. The second option is if the DCN in question is not where the subscriber should be. In that case, we will get the reroute NAS request, and the attach request will be forwarded to the correct DCN. To show you in a bit more graphical way, this is how it should look. Relatively simple. The device will send the attach request to the MME. MME, either random one or a fixed one, in this case, for example, a mobile broadband, will ask the HSS for this information. On the right side here, you see the profiles that we currently have deployed, set according to their speeds. So the gold one is the best one, the bronze one is the worst one. The identifier here identifies the slice, but this is just the name. The parameter we look for is actually here. So this is the UE usage type. So we have 10 for slice 1, 20 for slice 2, and 30 for slice 3. When Tirtha, in the last demo, provisioned the users, he provisioned them with S3 Gold. So both of those users are now provisioned in slice 3, according to this usage type, with the maximum speed allowed. So the HSS will send this information, so S3 max and 30 usage type, back towards the MME, and MME, in this case, will reroute the traffic for this subscriber to a DCN that is in defense. So it would reroute to another DCN, says here IoT, but just imagine this is defense. And the defense slice would then perform the registration, and the entire attach procedure would finish there. Now we can actually now go to the test itself. We can show you. That's why we have Paul and Terje in the car close to the antenna. We will now go with video directly there. So Paul, can you please share your video?
Hey guys, so can you see the video? Yeah. So now we are in the car on site. So just swap. Yeah. So I'm here together with Kenneth Nomeland from Defense. We have a lot of anti-back just to show you that, and we will run the test. So up on the roof here you see the base station, Jan Kenneth, and that's the 3.6 gigahertz 5G new radio from Ericsson. And we also have the LTE antenna there because of the anchor band. That is using 2.1 gigahertz. And the bandwidth we have on the 3.6 gigahertz is 80 megahertz. And now what we will show you is Kenneth is holding his phone, which is connected to 5G. So you can see that in the top of the screen. In the upper left there, it should be a sign of 5G. And that is now connected to the defense slice.
So in the future, Paul, it will say defense slice, correct? Or
yeah.
Defense.
Correct. So, and right now the profile configure for this is the gold. Actually, we had the gold provision for the EMBB, but Kenneth objected. He wanted the highest capacity on the defense slice. So we did that change before this demo. Now, what Kenneth will do is that he will run a capacity test just to show you what he gets there.
So what can we expect with 80 megahertz?
I'm not sure, maybe up to 700, 800.
When we go down to Rygge and use the millimeter wave, we have gigabit speed when we have close to 900.
Correct, that's correct, Kenneth. So in this test, it's not the millimeter wave, but the 3.6, correct.
So we will test the gold subscription here, the defense subscription, with 80 megahertz of bandwidth. Let's see what we can achieve with 80. You
see it?
Yeah, we have the 543 70.
Yes, that was it for the defense slice, and then I will hand it back to you, H.
Okay, thank you, Paul. Erlen, can you please share your screen now? Okay, now you should see the Erlen's screen. He's connected to the HSS, and he will be showing us where the users were actually now located, in which slice. So on top right, you can see HSS1, and on the bottom right, you can see HSS2. We are looking for the IMSI 233, which Erlen was nice enough to highlight. And here we can see that it was located in the HSS2. HSS2 is the one that is assigned to the defense slice. So when you see this located, it means that that's where the attach happened. The HSS between two different slices is not connected to each other. They are purely dedicated for their own slice. Here, Ellen also shown us the profile that is assigned to this IMSI. What we will now do is we will change the profile of this user. Usually, this would be changed by the flow 1, so the centralized provisioning. But here, for sake of simplicity, we will be changing this manually so we can do it faster. We will change the user to connect to slice 1, not to slice 3 anymore, and we will lower the assigned bandwidth from gold to bronze. If you remember, we had 3 profiles per slice, so gold, silver, and bronze, with bronze being the lowest speed. Since Erland changed this profile, it should now register in slice 1, and it should show much lower speeds. Since this was changed manually, I will be asking Kjell to just trigger the reattach procedure, because when changed manually, the subscription is not automatically updated for the phone itself.
That's been triggered. Yeah.
Excellent. So can you please, Erlend, just show us where it is located now, this IMSI? And as you can see, the IMSI has now been located in the HSS1, which belongs to slice 1. If we check HSS2, which is in defense slice, we will see that it is now purged. So it's no longer there. With this, I would like to go back to Paul with video to show the change in the subscriber behavior. Paul?
Sorry, yes, I was not. I was muted there. So okay, now can you see my video? Okay, so we are back in the car. Kenneth is still holding the phone, and now he's connected to the EMBB slice. But the EMBB slice has, as H told, got a bit lower capacity. So Kenneth, can you please run a speed test?
We can do that. We can check the bronze subscription. Start up again. Now we attach to the EMB slice. As you can see, much lower. Only 57 megabit per second. They have to.
Yeah, that's a bronze profile for the EMBB. Of course, that can be changed according to what we want it to be. Just to also show you that we are still connected to 5G. You see in the upper corner, hopefully, there should be a 5G symbol. So with that, I will hand it back from you, from the car to you, H, again. So thank you.
Okay, thank you, Paul. This has now shown that by changing the subscriber's information in the HSS, we can control where the subscriber is going to be. In the normal case, we would have one and only one packet core per network with several MMEs or something. But in this case, when we have multiple slices and we need to control it somehow, we use this usage type parameter in the HSS. Please note that since HSS are not, as I said, connected between them, this information needs to be updated in both of them. So the provisioning system needs to know where the user is subscribed and should accordingly update both HSSs. That would be it for this test. If you have any questions, I can take them now or later.
Thank you, H. That's good. That was the demo of the connection to the slices and showing also the differentiation between them. So now I will hand it over to Dima from PaloAlto, which will be showing the security as a service. So Dima, please take the floor.
Yeah, hi guys. So I'm going to share my screen now. Do you see my screen? Hopefully, yes.
Yes, we can see it, Dima. But Dima, we can only see the backgrounds.
So you cannot see. Okay. Share. What about now?
In the background.
Okay. What about now? Do you see Safari?
Yes.
Web browser. Okay, so before I start, I just want to show also what have been happening right now from the firewall perspective, because obviously the whole traffic was going through the firewall here, and also to prove you that guys are not. Yes.
Dima, we only see a white Safari on the top bar, but not only a white screen.
Okay, so I'm sharing the whole screen, but
We see the background.
Excuse me, I may try to help here. So, Dima, you are running WebEx on a Mac, so probably that's the first time.
I see it now. Yeah, I see it now.
Okay, it's the privacy. Exactly, screen recording. Okay, cool.
You see it now, right? So you see my screen.
Yeah, now it's better. Yeah.
Yeah. Okay. Good. So okay. So just first of all, you see the slides on the screen, right? Yeah. Okay. So first of all, just generally look into this architecture that we have been discussing. And in the beginning, what Antonius was talking about, we have the core side and we have different security classes and the core side, and we are separating the different security classes containing different type of network elements with the firewalls. So basically at the moment we have 5 firewalls on the core side, and those firewalls are segmenting this network into different security classes to assure that the most important network elements like databases are really secured and stand behind several firewalls. But today what I'm going to talk about this so-called firewall 5, which stands on behind the packet core. So basically firewall 5 connects the packet core to internet and doing the nothing for the traffic going out to internet from mobiles. Mobile phones, they have the private IP addresses, and then the firewall converts these private IP addresses into one public IP address, which is then going to internet. So as of today, firewall 5 current state is that we have multiple slices, and those slices have their own P gateways, and then these P gateways going out to internet using this firewall 5, which is doing this nothing and applying some security policies as well. We have two subnets with 10.24.0.0.16, which is mobile broadband, and then 10.30.16, which is the defense subnet. Then the firewall 5 nuts those addresses into internet. There is the separation, of course, between those subnets. They cannot communicate one to another, so firewall 5 takes care of that. And let me show you what I was showing, like the guys were doing these tests. And I can show you what was happening with the the defense slice. So the source IP address was 10.30.0.2, and then we have seen the traffic going out. And interesting that the traffic which was going out was identified by firewalls as Netflix, because that application that the guys was using to test the speed, that application is used the Netflix on the background, Netflix servers on the background, and I actually download those huge amount of data, big video files up and down. So I can confirm from firewall perspective that the guys were really downloading big amount of data, and that you can see here on the screen as well. Also, what I can show you here is a bit of collection of information for last couple of days. What have we seen in this particular network from the different application standpoint? So we have seen web browsing, we have seen Netflix. Again, that was generated by the speed testers. We have seen some Google-based traffic, Google Mail, Google Analytics, speed test, and so on. So already now with this firewall 5, we can have quite a good analytics of the traffic which passing through 5G network. But what is even more interesting to look at in the future is actually to differentiate different slices and have different firewalls for those different slices going out to internet. Why that would be interesting? Because there is the possibility here for this deployment to have so-called firewall as a service for each and every either customer who is using this lines like defense or different type of the traffics, like maybe IoT traffic can have one security policy types, mobile broadband traffic can have other security policy types. So what we have is the possibility actually to split that firewall 5 into multiple firewalls, either by virtual firewall deployment inside the slice, or splitting that firewall 5 hardware firewall into kind of sub firewalls or so-called virtual systems inside. And then actually there will be possibility to configure own security policies, possibility to configure own applications that this firewall would like to allow you to go to, own URLs that you want to, or URL categories that you want to allow or you want to deny. You can configure the antivirus on this firewall. You can configure DNS security. You can configure IPS and other security functions that we currently have been testing. So basically, also there is the great possibility here not just to separate traffic, the user traffic going into internet between subnets, but also there is the possibility to differentiate on the management traffic, meaning each and every of those firewalls at the end of the day can be managed by the verticals themselves if they would like to. For example, the defense guys have their own devices which are connected through this 5G network and go into internet or to some defense services. They can go through the firewall, which can be also given to defense guys to configure security policies, their own security policies. So you can imagine this 5G network as your own IT network that you own and that you have full capability to configure security in. So we have that possibility here. So what I'm going to show you is that I have created some kind of simulated environment inside here where we have two different user groups, and within those user groups, what I will do, I will configure the security policy on firewall, which for the user group will allow to use any application. It will have also antivirus capability and the anti-spyware capability, and also will not allow to go to the URL categories which are alcohol and tobacco. There was some question or? Okay. And then the user group 2 will not allow to go to Facebook, but it also will provide the antivirus and anti-spyware, and also will block alcohol and tobacco. So let me show you how this works. Okay, so here is this firewall, the specifically configured firewall. I actually have generated some interesting traffic also on this firewall, also just to show you how it can look when there is many users and there are much more traffic than just Paul have not simulated, but tested there with the speed tester. So as you can see here, there is quite an interesting information. So there is the different applications which have been used, and basically you can have the full control of those applications. Also, there is interesting things here that you can see, like the map where with the destination addresses where the traffic is going to, and so on. But let's jump to the policies. Let's jump to the different users and different policies. So I have configured these policies in the firewall, which allows, which denies user 2 from the group 2 to go to Facebook, and allows users from 1 go basically anywhere. Users 2 can go then also anywhere, but not the Facebook. Okay, and then also there's something called security profiles, where I have configured the antivirus, anti-spyware, and the URL filtering. Like in this URL filtering, I have configured block the alcohol and tobacco URL category. So now I will go to those machines, like this machine, which is, as you see, called Windows 7 user group 2. And I will try to go to Facebook. When I'm trying to go to Facebook, I'm getting this message that application is blocked. And it is blocked because we have such a configuration. Then if I go to user 1, where I can try to go to Facebook, and here basically I'm allowed to go to Facebook because for this particular user, Facebook is not blocked. Then I will try to download the sample malware file. So basically this is the test malware file that is located on icar.org, and I want to try to download that file. When I press to download that file, I'm getting the message that this virus has been blocked because it is virus, obviously, and I have that security policy configured. And let me try to go to some normal website, let's say vg.no. When I go to vg.no, it is allowed, and I can go there. And then the last thing I'm showing here is I will try to go to the vinmonopol.no, which is alcohol and tobacco category. And obviously, I'm not allowed to go there because this is the alcohol and tobacco category. Just to compare the things here, when I try to go to the application, which is not allowed, it says application blocked. When I try to go to web page, URL which is not allowed, it says web page blocked. And if it's virus, obviously it tells me that this is virus or spyware, and then download was blocked. And the last thing I want to show is that the DNS security, basically the anti-spyware profile, the connectivity to the command and control servers using the DNS. So basically, if the device is already infected, and then this device tries to connect to command and control server for the getting the commands to execute some malicious activities, the firewall also can see that and do something called SYN calling, meaning the firewall will not resolve the address of that DNS of that domain, but just resolve it, for example, to the local host instead. So let me go to the second device here. What I did, actually, I have created the script which runs the DNS resolution, which basically runs NSLOOKUP for the domains in this baddomain.txt file. So I run it, and as you see, all resolutions are returning 127.0.0.1. So, which means that the firewall sees that this is all of those domains which you see on the screen. They are basically malicious domain and command and control domains, and firewall just says to the device, okay, the IP address of that domain is yourself. So it does not allow to resolve real IP address and doesn't allow to go there. And that is, as a result, we can look also into the monitoring here, and we will be able to see that this spyware, the malicious domain have been sinkholed, and firewall does not allow to go there. Also, we can see that we also can see here another type of activity which is also was blocked, which was the attempt to download the virus. So virus also have been prevented. So basically, that was this type of the short demo. But the most important thing here that within this setup of 5G-VINNI, we can provide the capability to secure the traffic of the end users also per slice, and even give the capability to the say defense people to manage their own device. And the last thing I'm showing here is exactly that. I have configured the user for the defense guys, and if I go to the defense guy admin, which is different from the overall admin, we can see that as the defense admin, I can go to the firewall, but what I have done intentionally is that I only allowed this defense guy to configure only certain security rules. So in my admin menu, in the super user admin, I had a lot of different capabilities to configure in each and every of those tabs here on top. But for this user, which is the defense user, I decided to configure, to allow him only to configure the security policy rules, but for example, not NAT rules or not quality of service rules, and so on. Okay, that was it from my side, and just bringing up the slide with the firewalls per slice here. And if you have any questions, please go ahead and ask.
Okay, thank you, Dima. Any questions to Dima on the security as a service? No? Okay, then I think this is what we had to demonstrate for today. So I think the floor is open for questions to basically everything we have talked about today. And if you want to ask other questions as well, that's of course also fine. So please raise your hand and or just shoot out if you have any questions.